Welcome back to the deep dive. You know, if you've ever hit that wall around, say, 3 p.m., that really heavy, just unshakable fatigue,
Mm.
where you feel like you're running on fumes even if you maybe got 8 hours sleep.
Oh, yeah. We all know that feeling.
You just wished you had that steady energy, but, well, often you're just told, oh, maybe you're stressed or, it's just part of getting older.
Exactly. And that's often the most frustrating thing you can hear, right? Because it doesn't really get to the root of the problem. But we've gathered some really fascinating research today looking at one specific molecule. Science shows it's, well, absolutely foundational for fixing this energy issue right down at the cellular level. It's called glutathione.
That's it. And when we talk about glutathione, we often use that acronym, IDA, Immune, Detox, Energy, and Antioxidant.
Mhm.
So today, we're really zeroing in, laser-focused, on the E energy. Our mission, if you like, is to figure out exactly how glutathione keeps your internal power grid, humming along strongly all day. We want to go deeper than just stories. We're actually going to look at the mechanics of how energy gets made.
And yeah, this isn't about some quick fix. The source material we've looked at, it confirms that having good, robust glutathione levels directly links up with measurable improvements. We're talking better physical endurance, sharper thinking, even better, more restorative sleep.
Deeper sleep, wow.
Yeah. So to really get why this happens, we kind of have to start small, really small.
Okay, so let's dive into that. The cellular engine room, basically.
Mm-hmm.
I mean, you are this incredibly complex machine, right?
Hmm.
Made of specialized parts, tissues, your muscles, liver, brain.
Right.
But ultimately, all those tissues are built from tiny, highly specialized cells. They're the basic units doing the work, and they constantly need fuel.
Absolutely. And every cell has its own internal machinery, but the specific bit the machine really designed just to produce energy, that's the mitochondria.
Ah, the famous mitochondria.
That's them. You can sort of picture them like tiny little power stations inside the cell, or maybe miniature batteries. They generate the chemical energy the cell needs for everything moving, thinking,
The
communicating.
little generators.
Hmm.
And I read somewhere that the number of these little power plants,
Mm.
it varies hugely depending on the cell.
Oh, massively. It tells you everything about how much energy that cell needs. So a cell that's not very active, maybe like a fat cell just storing stuff, it might only have a few mitochondria.
Okay.
But then you look at a really active cell, like a liver cell, it's working nonstop, 247 metabolizing things. Or think about a neuron in your brain firing constantly. They can house thousands of mitochondria, just thousands, because their energy needs are enormous.
Wow, thousands in one cell.
Yeah. And here's the thing, sort of a universal law when it comes to making energy. Doesn't matter if you're burning wood in a campfire or gasoline in your car or, sugars inside a mitochondrion.
There's always a catch.
There's always a trade-off. Generating energy always, always produces two things you have to deal with.
Okay, what are they? Let me guess. Heat,
Heat is number one, absolutely. Just like your car engine gets hot.
exhaust, waste products.
And waste products, burnt fuel, exhaust, exactly. Your car needs a radiator for the heat, right? And an exhaust pipe for the waste fumes. Well, our mitochondria, they're no different. As they're busy turning nutrients into energy, they generate a lot of heat and also a very, let's say, dangerous type of waste product.
Okay, dangerous waste. So not just regular cellular trash we're talking about.
Mm.
What is this exhaust from the mitochondria, and why is it so bad?
Well, the waste products we're really concerned about here are called free radicals. They're basically unstable molecules. They're missing an electron, chemically speaking, and they're desperate, like really desperate to grab one from anywhere nearby.
Okay, sounds disruptive.
It is. This frantic scavenging action creates what scientists call oxidative stress inside the cell.
Hmm.
It's not just about cleanup, it's actual damage happening to structures.
So if the mitochondria are little generators, this oxidative stress, it's like they're running too hot, and maybe the internal parts are actually getting, corroded, rusted by these free radicals.
That's a great way to put it. Corroded, yes.
Hmm.
When these free radicals build up, they start attacking whatever's close by. They damage the mitochondria's own membranes, they mess up important chemical bonds, they basically destabilize the whole environment the cell needs to function properly.
And the result?
The generators slow down, they become inefficient, and eventually they can just fail altogether, burn out.
But wait, doesn't the cell have systems for cleaning up waste generally? Why is glutathione specifically the hero here? What makes it so critical?
Ah, good question. Because glutathione is the specialized defense, it's the body's master antioxidant, specifically designed to handle this kind of molecular chaos caused by energy production. Think of it as the mitochondria's dedicated cooling system and neutralization agent, all rolled into one.
A cooling system. I like that.
The mitochondria are utterly dependent on it. They need glutathione to soak up that excess heat, metaphorically speaking, and crucially, to neutralize those damaging free radicals before they wreck the place.
So without enough glutathione,
Yeah.
it's like trying to run thousands of those powerful generators inside a tiny room with no ventilation and no way to put out small fires.
That's a perfect analogy.
Yeah.
Yeah. Without glutathione keeping things under control, the whole energy-making process starts to destroy itself from the inside out. The research is really clear on this. Without enough glutathione, our mitochondria would literally burn up and stop functioning.
Burn up. Wow.
Glutathione is absolutely essential to cool things down and keep those power plants running.
Okay, this is where it gets really, really interesting for everyone listening, I think, because this microscopic stuff, this glutathione role, it doesn't just stay in the cell. It directly impacts how you feel, how you perform, like every single day. So how does that actually work? How does this cascade out to affect the whole body?
Right, we can definitely connect the dots. We can see how vital this defense mechanism is by looking at its impact on three key levels, three tiers, if you will.
Okay, let's break it down. Tier 1, the molecular level. What's happening right down there with the chemicals?
So on the molecular level, it starts when your cells burn nutrients, oxidize them to release energy. That process, as we said, inevitably creates those unwanted byproducts, the free radicals.
Right.
Now, if you've got plenty of glutathione around, it jumps in immediately and neutralizes them. Threat over.
Yeah.
But if your glutathione supply is low, those radicals are just left running rampant. They start damaging crucial things like proteins, fats, altering their structure. It's like a series of tiny explosions going off inside the engine room.
Not good, especially in hardworking cells, I imagine.
Exactly. If that's happening constantly in high-demand cells, think muscles, nerves, the damage really adds up fast.
Okay, so that's molecular damage. What happens when we zoom out a bit to the whole cell, the cellular level?
Well, at the cellular level, glutathione's job is ensuring that energy production can keep going smoothly by protecting those mitochondria at the power plants. If the mitochondria get damaged by that oxidative stress we talked about,
They can't work properly.
they can't run efficiently, no. And worse, damaged mitochondria actually start producing even more free radicals. It becomes this nasty, vicious cycle.
Okay, a downward spiral.
Glutathione basically interrupts that cycle. It protects the mitochondria, keeps them intact, allows them to keep pumping out energy consistently. It's the difference between having, smooth, reliable power versus dealing with constant brownouts or surges.
Okay, I can really start to see the connection now. Like when I feel that mental fog creeping in late afternoon, is that basically my brain cells kind of struggling to manage the waste generated from a whole day of thinking and processing.
That's a very likely part of it, yes. And that brings us perfectly to the third tier, the whole body level. Because if your individual cellular engines are running hot, getting clogged up, feeling sluggish, well, their ability to contribute to complex tasks just drops off.
Right.
And this impairment hits you right where it counts, maintaining your physical stamina and your mental sharpness.
You give maybe a couple more sort of everyday examples of how that system failure feels?
Sure, absolutely. Think about muscle recovery after exercise. When you push yourself hard, your muscle cells suddenly need a massive amount of energy, right?
Yep.
That creates a huge spike in oxidative stress. Now, if your glutathione levels are low, that stress hangs around for longer. It means more soreness, feeling fatigued for longer. Maybe your endurance doesn't improve as fast.
Makes sense.
And similarly, in the brain you mentioned, brain fog neurons have incredibly high energy demands. So if glutathione isn't there to manage the waste efficiently, it translates directly into what you experience as mental fatigue, maybe difficulty concentrating, that general feeling of just being slow.
Yeah, sluggish.
The speed and clarity of your thinking really depends on those little mitochondrial power plants running cool and clean.
It really paints a clear picture then. It sounds like the easier our cells can get hold of good supplies of glutathione, the better our energy production is going to be pretty much across the board, from how well we recover physically to how sharp we feel mentally.
That's the core of it. It's the foundational defense mechanism that allows for high-level function and makes it sustainable day after day.
Okay, so our cells need energy constantly, They need protection constantly. You said the body makes glutathione all the time, which makes sense. We're designed to handle this. But here's the big question then. If our bodies make it naturally, why do so many of us seem to struggle? Why might levels be low?
That is really the crux of the issue in, modern life. Our bodies are designed to make it, yes. But various things constantly drain our supplies, often faster than we can replenish them.
Like what?
Well, think about chronic stress. Poor diet definitely plays a role.
Hmm.
Environmental toxins we're exposed to, illness. And maybe one of the biggest factors is simply the natural process of aging. All these things increase the burden, the metabolic load, and therefore the demand for glutathione. They just deplete the reserves.
So the system's working, but it's kind of getting overwhelmed or drained constantly?
Yeah.
Okay. So it sounds like supporting this natural production, that's got to be key. But why not just, I don't know, take a glutathione pill? Seems simplest.
Yeah, that's a really common question, and it gets to a fundamental point. The issue is if you swallow glutathione directly, your digestive system is actually pretty good at breaking it down before it can get absorbed properly and make it into the cells where it's needed.
Okay, so it gets dismantled.
Often, yes. The body is much better at using its own glutathione that it makes internally, but to do that efficiently, it needs the right raw materials.
The building blocks. So we need to give the cell the components it needs to actually build its own glutathione shield.
Exactly that. You've got it. This internal production, it can be supported really effectively by providing the body with what we call a natural precursor.
Precursor, meaning?
Meaning the basic building blocks, specific amino acids that the cell uses to construct the glutathione molecule itself. By supplying these precursors, you're essentially empowering your own cells to manufacture and recycle glutathione much more efficiently. It ensures they can maintain those optimum supplies needed for continuous energy and constant defense against those free radicals.
So it's about giving the cell the right tools, the right fuel, so it can keep those thousands of little generators running smoothly and coolly.
Precisely. You're helping the body do what it's designed to do, just better.
Well, that brings our deep dive into the ease of idea energy pretty much to a close. I think that the central message really is that glutathione isn't just some general antioxidant floating around. It is absolutely foundational, critical to sustaining our energy levels. Why? Because it manages the unavoidable waste, the heat and those free radicals that comes from our mitochondria just doing their job. And without that crucial cooling and cleanup system, the whole process of making energy starts to damage itself, it stalls out, and that's when we feel that fatigue, that dip in performance.
Exactly. And maybe here's a final thought, sort of provocative idea for you listening to Chew On, based on all this science.
Go on.
Given just how dependent our energy production is on managing this oxidative stress, what other health issues that seem completely unrelated, maybe things like, I don't know, unexplained mood swings, or perhaps recovering really slowly after just a minor cold, might actually trace back at some level to the efficiency of these tiny cellular generators and their need for constant glutathione defense.
That's fascinating.
It really makes you think differently about cellular health, doesn't it? And how it connects to everything else.
It really does. A mind-expanding concept for sure. Now, if you do want to dive even deeper into this topic, explore some more of the detailed mechanisms, how glutathione supports all these essential functions, maybe learn a bit more about those precursors we mentioned. We've put a link in the description where you can find more information.
Great stuff. Well, thanks for tuning in to The Deep Dive.
Yeah, thank you for joining us. We'll catch you next time.